Okay, so this question gives us a cost function and a revenue function. It says an accessories company finds that the cost and revenue in dollars of producing X belts is given by the following. Okay, so it says determine the rate. This is what we need to find. Determine the rate, right? The word rate indicates derivative for us. So we already know we're going to be doing a derivative of something. At which the accessories company's average profit, that's another keyword we're going to need, average profit per belt is changing when 176 belts have been produced and sold. So we need to find the derivative, right? It says determine the rate, and in particular, the derivative of the average profit function. So if you consider the fact that we can start with the definition of profit being revenue minus cost. Let's start by getting, there's a couple ways you go about it. I think it's easiest to just go ahead and get the profit function, right? And then we'll worry about getting the average. Okay, so the profit function is going to be, let's see, 35x to the 9/10 minus, and we have multiple terms for the cost function, so make sure you use parentheses here or you get your signs wrong. So minus 720 plus 30x minus 0.066x squared. Okay, just double check that looks good. Okay, so we'll skip the simplified real quick. It looks like the leading term, it doesn't really matter if you're not in descending order, but I like to put it in descending order. Our lead term is going to be, if you notice, we got a minus times a minus, that gives us a positive 0.00, oops, just 10, sorry. Here we go. 0.066x squared, and then we got a minus 30x. This term's a positive term since it's out front, 35x to the 9/10, and then we get the minus 720. Let me just double check. We should have 1, 2, 3, 4 terms. 1, 2, okay, good. Again, if you don't have it in this order, it's not going to matter, but this is the order I'm using. Okay, so this is the profit function. Remember, we have to find the rate, so we need a derivative, but it's not the profit function itself, it's the average profit function. So if you consider how you would find an average, right, you'd find your total. So let's say I made a profit of, for 100 items, let's just say I made $1,000. That was my profit for 100 items. Well, if I want to know what I made per item, I'd have to divide by 100, right? $1,000 per 100 items, which means I made $10 per item. So the way to get the average function is just to divide by whatever its input is, the x. So there's different ways to notate it. I noticed in MyLabs Plus they're using like a p hat or a p with a little bar above it. You could also, I was doing the average profit function, writing it like something like that. But the key is, it doesn't really matter how you write it. It's just not p of x, right? It's different because we're dividing everything by x. So I'll stick with MyLabs Plus and put a little line over it. So our average profit function is, we're going to divide, it's easiest to divide every term individually, rather than dividing the whole thing by x and trying to do the quotient rule, right? If I divide the first term by x, then I have x squared divided by x is just now a single x. Minus, here if I divide this term by x, the x cancels. Here if I divide this term by x, remember the rule is when you divide like bases, in this case x, you're going to divide these two, you need to subtract the exponents. Right, so x to the third over x squared, for instance, is just x to the 3 minus 2. Well, in this case, if we're dividing that 35x to the 9/10 by x, we have to consider that 9/10 being subtracted by 1, because the exponent on a single x is 1. So it's x to the 9/10 minus 1. You can do it in the calculator if you'd like, or you can think of it as 9/10 minus 10/10. But that's going to be x to the negative 1/10. And then if you divide 720 by x, it's just a single x on the bottom, which, divided by x, for instance. I'm going to write it in the numerator's place so that we can stick with the power rule when we get the derivative. So rather than writing it over x, let's put it as x to the negative 1. So this is the average profit function here. Now what we need is the derivative, right? Because that's the tricky part to this stuff, is you do all that work and you maybe forget one of the steps. We had to find the average profit function. So we found the profit function, subtracted the revenue from the cost. Then we divided each term by x to get the average profit function. Now we're ready for the rate, right? The rate at which the accessories company's average profit per belt is changing. So let's notate this as a derivative. And our first term is linear, so from the power rule, just bring the 1 down, and x to the 0 is a 1. Derivative of a constant is 0, so we don't need this term, it goes away. Here the negative 1/10 comes down in front, so we'll have a negative, right? It's negative, and if you think about 35 times negative 1/10, well, that's negative 3.5. That should be fine as a decimal, or we can think about it as, what would that be? 35 over 10, that's 7 over 2. Maybe, I'm partial to fractions, honestly, so I'm going to write that as 7/2, but it doesn't matter. Just be careful with decimals. Decimals go on forever in things, and you're going to need a fraction. All right, so we got minus 7/2 x. Now we're going to subtract 1 from this because of the derivative now, right? It just so happens that when we divided by x, we subtracted 1. But in this case, we're doing a derivative, right? So you bring this down, subtract 1 from the exponents. We have negative 1/10 minus 1, which is 10/10. So we have negative 11/10. Again, you can always do it in the calculator if you don't like fractions. And then we've got a minus times a minus as a positive 720 x to the negative 2. So this here is the average the rate at which the average profit function is changing per belt. So there's probably a part in this problem where they just want you to plug that in. So there's a few forms. If you just went with the quotient rule, meaning like dividing everything by x instead of the way I did it, which was to divide each term individually, you'll get the same result. It might be a little bit harder in terms of the algebra, but it'll be equivalent. It might look slightly different, but it'll be equivalent value and it'll work. So this should be the rate at which average profit is changing. Now they also ask for a specific value. They say, what is the rate per belt at 176 belts? So at the 176 belt point in production, what's going on with our per belt average in terms of profit? So what you need to do for this, and I'm going to pause this for a moment so I can get my calculator. You just go ahead and evaluate this function in the calculator. The calculator is, so we have 176 belts again. So there's multiple ways you can go about evaluating. You can use the y equals function. That would be my cat. All right, so I think the easiest thing to do, since we're only having to evaluate this once, I already forgot the number, 176. You can just type it in parentheses here. Or another way you can do it, a nice little convenient trick, is you can take the number 176, since that's what they gave us, and you can store it. So you type it in and then press the store button, which is the button above the on, get the little arrow, and then type the variable button. And that'll store it to x. So now x is 176. And this is not, don't worry about this changing any settings in your calculator. This is not going to change any of the x's you need for the modules inside the calculator. It's just a simple tool you can use to evaluate. So now, because x is 176, we can just type the equation in. So you can do 0.066 minus, I got 7/2 there, x, and then you can do exponent. Be careful with exponents. If you don't have an auto script like this, you're going to need parentheses. Like I have a little auto script from this calculator since it's a plus version, so I don't need them. But if you have an older model, make sure you put your parentheses in, or say put your exponents in parentheses. All right, so divided by 10, and then drop the arrow down. We've got a plus 720 x to the negative 2. All right, so if you hit enter for that, you should get a value. And however, it wants you to round in the problem. And it turns out, so at the 176th belt point in terms of production, they're seeing growth in their average, their per belt average, by approximately 8 cents per belt, right? If you were to round that up to the nearest hundredth. But that's how you would do that problem. Hopefully that helps. If you have any further questions, feel free to let me know. Thank you. Bye.